Good morning, Algebra 3 class. I'm glad that all is well with you, and I hope that it is. And if it isn't, please let me know so I can pray for you, and just make sure that you're reaching out to somebody with your needs, even if it's not me. Just make sure that you're reaching out to somebody. So here we are, we're ready to jump right in on the graphs of the translations of sines and cosine functions. Now we did a little bit of analysis when we looked at a basic sine function the other day, but with that we were doing basically just a change in amplitude where the graph got to be stretched out a little bit higher, or a change in the length of the period so that it scrunched up or that it spread out a little bit. We had noted that they always started at 0 and then it went up and then down and then back up again. So we want to make sure that you're realizing for sine that that's your basic pattern, and for cosine, remember it started up, went down, and then up again. And you want to keep in mind your basic patterns whenever you start thinking about how to graph a sine or a cosine function. Now, in subsequent sections, we're going to be talking about tangent, cotangent, secant, and cosecant, but we have to be able to master the sine and cosine first because the others are based off of that. All right, so looking at this one, okay, if you remember from the other lesson, an important thing that you need to do is that you need to take whatever you're taking the sine of is really between 0 and 2 pi, because the period for a standard sine function is from 0 to 2 pi. So we need to do that same thing again. You want to put this piece, because that's what we're finding the sine of, between 0 and 2 pi. And what that's going to do is it's going to help you figure out what this change does to your sine function. And when we do that, what we find is that really what it's doing is it's going to be moving it so that it's not starting at 0 anymore. It's going to be moving it to a new place. So when I add pi over 3 to all three of these zones to try and get x isolated in the middle, 0 plus pi over 3 is obviously pi over 3. 2 pi plus pi over 3, well, that's really 2 plus 1/3, which is 7/3. You do always make them as improper fractions for these. So we have our beginning of one period is pi over 3, and the ending of one period would be 7 pi over 3. Now, just like we did in the last lesson, you need to find the middle. So just like we did in the last lesson, we're not adding 0 this time. We're adding pi over 3 and 7 pi over 3. So when we do that, we add them and we multiply by a half because we're looking for the middle. What we find is 8 pi over 3 times a half is 4 pi over 3. That's your middle. Then you need to find the middles of these two so that you're finding your nice even increment. Some people would have a little bit of a different way of doing this, but I'm going to stay consistent on this because I really want you to have a good understanding going forward. Yes, there are shortcuts that you might learn as you're getting more familiar with trigonometry and as you go on. But this is good because I want to emphasize that the even increments are important. If we use this method to find them, it's making it more obvious that it has to be exactly in the middle because of the dividing by a half, or multiplying by a half, dividing by 2. And so that you're getting the idea that it does have to be in nice, steady gaps, and that a sine wave is a very regular type of thing. It's regular because, remember, it's based off of the unit circle, back to that. So it is cyclical, It's periodic, we call that. And so we are emphasizing that in the way that I'm choosing to approach this. So we add pi plus 4 pi over 3, which is 5 pi over 3. So when you take that, a half of that, we get 5 pi over 6. And over here we take this one plus this one. 4 and 7 is 11. Times a half gives you 11/6 pi. And what may or may not be obvious is it's going up by sixths if you look here, because 5 pi over 6, if you went, if you're going up, so it's really going up by 3 pi over 6, because 5 pi over 6 is going now to 8 pi over 6. So that would give you a 3 pi over 6 that it's going up by 8, 9, 10, 11 pi over 6. 12, 13, 14 pi over 6, which reduces to 7 pi over 3, which is another method that sometimes people will use to find out how far the gap is, how far it's going up by. But anyway, back to our idea of making sure that we're getting nice even increments. You add and multiply by a half. Add and multiply by a half to get those middles. Okay, so when we begin to graph it, we're going in the interval from 0 to 7 pi over 3. Right in between those two, if you were making the next mark, would be 4 pi over 3. Right in the middle of those two would be 5 pi over 6. And right in the middle of those two would be 11 pi over 6. Now your graph this time is not starting at 0. Your graph for one period of this function starts at pi over 3. It starts just like a normal sine curve, and you're going to follow the pattern. You're going to go from the middle, then go up, then to the middle, then down, and then up. So you're bouncing around that center line, and each one of these spots gets a dot. Another way that you could think of it is, okay, I want the beginning, the middle, and the end for a sine curve to all be at this baseline, and then bounce up and bounce down. That's another way of thinking of it. But either way, your sine curve has to be consistent. It has to go up and down and up. And really all that happened was we took that curve and you moved it off of 0 and you shifted it pi over 3 to the right. So each one of these points is pi over 3 to the right of where your standard sine curve would be. Notice that I was very careful to keep my amplitude at 1 so that it goes up 1 unit and it goes down 1 unit. This can be done with a simple piece of lined notebook paper to make a really good looking graph where you're going up 1 unit and then you're going down 1 unit. Make sure that you take that whole gap. Don't cut it off in the middle, because that's not showing an understanding of the amplitude or how far up and how far down it goes. I will be looking for things like that when you start submitting graphs. This will be something that I'm going to have you send to me so that I can see what you're doing when we get a chance to do a quiz or a test. I'm not going to be able to do that with the submission forms. It'll be a little different. Okay, so we're going to look at another one. Okay, if you remember, when you had a number out here, and you had a regular thing, like if you just had a cosine x and you didn't have this craziness over here, this number is actually going to tell you the amplitude. It's going to tell you how far up and how far down it goes. Notice we're also dealing with cosine. Cosine means that it's one of those graphs that's going to start up and loop down and come back up again for its one period. So let's take a look at what all these numbers are telling us. First of all, the 3 tells us that the amplitude is 3, so you're going to be going up 3 and down 3. This gets put between 0 and 2 pi. And this is going to be your standard operating procedure for making sure that you get this done between 0 and 2 pi. So to get the x isolated in the middle, you need to subtract pi over 4 from each of these numbers. So this takes us into the negative zone. Negative pi over 4. 8 pi over 4 minus pi over 4 gives you 7 pi over 4. You can do that with fractions if you want in your calculator and make sure your answer is a fraction and then stick a pi on the end of it. We then have our beginning and we have our end. So this is our period is running from negative pi over 4 to 7 pi over 4. We need to find the middle, add them, and multiply by a half. This would give you 6 pi over 4, which would be 6 pi over 8, which would reduce to 3 pi over 4. Then you need to find the middle of the middles. This one and this one, negative pi over 4 plus 3 pi over 4 would give you 2 pi over 4. And then multiply that by a half would give you regular pi over 4. So 2 pi over 4, 2's will cancel and you'll end up with pi over 4. 3 pi over 4 plus 7 would be 10 pi over 4. Multiply that by a half and you end up with 5 pi over 4 after you reduce it. So we have these are our nice even gaps. So when you make your single period for this graph, what you'll do is make sure that you're going to go up 3 and down 3 from your 0 baseline. Your important spots are going to be negative pi over 4. Now that tells me if I'm going to go negative pi over 4, I'm going to have to make pi over 4 gaps as I go along. Not every one of them is our special points, but just so that you're keeping your increments even. If I do negative pi over 4 this way, it takes pi over 4 to get here and another pi over 4 here. So you're thinking about fourths. So negative 1/4, 0, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. Just so that you've got a nice look to your graph. You're going up 3 and you're going down 3. Remember, in the case of the cosine, it's this value and this value, which is going to be where your baseline is. For a cosine, you start at the top, you go down through this point, you go down to the bottom at this point, you turn it around, you come up, and then curve like this, making 100% sure that you do not make it go up like this. Remember, this thing would continue on and on and on. And every period would have a nice complete amplitude. It's not going to be getting lower. It's going to have a nice complete amplitude with this particular cosine function. Okay, so notice the directions changed here. We're not going to do just one period. We're going to need to analyze so that you can go for 2 periods on this particular graph. So in your effort to go 2 periods, we start off with the same thing that we started with, just to analyze what's happening for 1 period. And when we analyze what's happening for 1 period, you will take this and you're going to put it between 0 and 2 pi. We subtract pi from each of the 3 zones, divide each of the 3 zones by 3, and we have our 1 complete period for cosine going from negative pi over 3 to pi over 3. We need to find the middle. If I add negative pi over 3 and pi over 3 and multiply by a half, I get 0. I don't even have any work there, but it's kind of easy to see because they ended up being kind of bookends here. 0 makes sense for being directly in the middle. Negative pi over 3 plus 0 times a half is negative pi over 6. 0 plus pi over 3 is pi over 6. So that gives us one complete period. So we're in our minds, we're kind of picturing right now up and then down and then up. But we need to figure out, well, wait, how do I get one more cycle of that? In order to do that, you're considering this is the beginning of your next cycle, so you need to go 4 more beyond. What you'll need to notice is you need to notice for each one of these how big of a jump it is to get to the next one. And as you've got 5 values, you can pick the one that's going to be the easiest to find out, because you know that each one of these gaps is going to be the same. So what this tells me here is that every gap is pi over 6 or 1/6. From here to here, I'm going 1/6. Then this would be 2/6. That makes sense? 2/6 is really 1/3. So I have 1/6, 2/6. If I want to keep going, I get 3/6 and 4/6 and 5/6 and 6/6. So once again, you figure out one of the gaps. 1/6. This would be 2/6. 3, 4, 5, 6. Because you want to keep it going at a nice even rate. And that would give you the extra period that you need. You do your basic 5 and then put 4 more on so that you're ending there. But we don't like to have these fractions unreduced, so you need to reduce the fractions. So 3 pi over 6 turns into a half. 4 pi over 6 turns into 2/3. 5 pi over 6 doesn't reduce, and 6 pi over 6 turns into pi. So when you make your basic graph, you're going to want to make sure that you include all of these values. Oops. You want to include all of these values. We also have to take a look and think about this part right here. Okay? And when I think about this part right here, this -2, -2 tells me, first of all, that I have an amplitude of 2. And then the other thing that it tells me, instead of going up, down, up, it tells us that that flips over, and my pattern, instead of being up, down, up, is going to be down, up, down. This negative flips the whole thing upside down. So that's important for you to note and pay attention to. So what we have here for this graph, we have all of the points. You have amplitude of 2, which means you're going up 2 and down 2. Here's your negative pi over 3 and your negative pi over 6, 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi. So moving right along with these. At even increments, it's an upside down cosine. Regular cosine starts up and slides down. This one starts down and slides up. Now be careful, one of the dangers is people forgetting the middles. So there's got to be a middle between every down and up, a middle between every up and down. So when you find your nice even gaps, make sure you don't forget the middles. So I'm going down, middle, up, middle, down, middle, up, middle, down. Do not forget the middles. And what this gives me is a nice upside down cosine function, and then a second one, and the second one is the second period. And then notice that the curve is ready, that you know that there are infinite periods beyond, and there are infinite periods beyond here that hit the same pattern. You're going up, all the way up the 2 because of the 2 here, and all the way down the 2 because of the down. And if you need to go back and rewatch some of that, that might be a good idea, because this is new. This is something that you will get good at, but you've got to make sure you're paying attention to all the details. Once again, a negative means that whatever your base function is flips upside down. This number right here tells you your amplitude, how far up and how far down for a complete good cycle. The part that is right here, anything that comes after your sine or your cosine, this part determines where that one period is going to land. It tells you the shifts. So this one shifted to the right pi, to the left pi, but then it wasn't a whole pi. It was then divided by 3 because of this 3. So doing this method is always going to get you your good set of 5. And then once you've got your set of 5, you can extend it by figuring out the gaps. Okay, so this one's got a little bit more in it. This one has this extra 3 here. So this extra 3, let's take it super slow, because every single thing in this has something that it does to what our basic function looks like. Once again, we're dealing with a cosine function. So that one in the normal would start up, go down, and then come back up. This 3 tells us that not only is it cycling around, but the whole graph is going to go up 3 units. Because whatever this is doing, this extra 3 adds 3 to the values and just sends the whole thing up. This 2 means that it has an amplitude of 2. This negative has an effect also. This negative means that the whole thing is going to turn upside down. So we've got everything that can possibly be happening here. This coming after the cosine puts it between 0 and 2 pi. So we solve then and get get x alone in the middle. Here's our beginning and here's our end. Here's our beginning, here's our end. We need to find the middle, so add the beginning and the end and multiply by a half. So a half of 2/3 is 2/6, which is 1/3. 0 plus a third is 1/3, times a half is a 1/6. 1/3 plus 2/3 is 3/3, which is 1 pi, but we divide it by a 2 or multiply by a half, and that gives us pi over 2. So now we have our nice single period here. You can either go ahead and extend it there, or you can say, okay, I'm going to handle one period first and then I'll extend it. So notice though what happened here. What happened is that the whole graph, here's my key location, 0, 1/6, 1/3, 1/2, and 2/3. But my whole graph shifted up 3 units. Notice I've made a dashed line here to substitute for the x-axis. The other graphs were always cycling around the x-axis. This tells us bump the whole thing up 3 units. Notice that I've also specifically marked 1 and 5. That's because the amplitude is 2. It's going to be bouncing from 2 units away from this new baseline. It's going to be going up 2 units and down 2 units from the 3. Now the other thing that we have to notice is we have to notice this negative. because the negative tells us that when we're bouncing this thing around, we're going to start down and go up rather than starting up and going down. So we're going to put our points in. We're going to go down, middle, up, middle, down, and that'll be one of our periods. So I'm going to put that in. I've got down, middle, up, middle, and down. There's one of our periods for our upside down cosine. Also, we need to go 4 more, and here's our calculations for our 4 more. We can notice that the gap is 1/6, 1/6, 2/6, 3/6, 4/6. That should make sense. 1/6, 2/6, 3/6, 4/6, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 sixths. Reduce the ones that are reducible. That keeps your gap the same. So here's 5, 6, 6, 6, 7, 6, 8 sixths. As long as your gaps are nice and even, if it gets too crunched to write in all the values, make sure that you're writing in enough to show that you know what you're doing, and make sure that somewhere you have these numbers so we can tell what you're doing. Then you'll need to extend that to keep going. We went down, middle, up, middle, down. Then we have to go back to the middle. And then we have to go back up. And then we have to go back to the middle. And then we have to go back down. Notice that we're taking up the entire amplitude. The entire amplitude. And then you very carefully sketch in your graph, making sure that it looks curved on the bottom because you're anticipating that it's going on and on and on. So we have our cosine. If it were a sine, it would start with the middle and cycle up and down through the points. Okay, let's do another. We are getting there. I know this is a lot to take in, but I have faith that you guys are going to watch this whole thing and are going to do great. Okay, this one is a sine graph. We needed to do a sine one. We hadn't done a sine one yet. So super important that we represent everything. All right, time to analyze before we even start making a graph. We have to analyze everything. Our -1 out here that's really just kind of hanging out and not really attached at all tells us the whole thing is going to move down 1. Our normal sine curve, you want to have in the back of your mind that my normal sine curve starts down and goes up and then down. So it starts and immediately goes up and then down and makes a curve like that. This too tells us amplitude of 2. I hope I left enough of a gap for you to think. Remember, a regular sine curve has a period of 0 to 2 pi, so we want to put this in here to figure out what the shift looks like. Solve for x. Subtract pi from all the zones. And then after you subtracted pi, you need to divide by 4. So we have one of our periods going from -pi/4 to pi/4. It'd be a very skinny little graph if we were realizing that it's now cut everything down into a very small increment. But the good thing is that if you're making your own graph, you can show the size a little bit more easily to watch, but realize that it really, if it was a standard going from going along and comparing to one that had a wider gap, it would actually be just more scrunched up. So we need to find the middle. So -1/4 plus 1/4 times 1/2 gives you 0. There's your middle. Negative a fourth plus 0 times a half would give you negative pi over 8. 0 plus pi over 4 times a half would give you pi over 8. We need to extend this further. So think about, okay, what are my gaps? If these are a little hard to check, pick the easiest one. If there's a 0 in there, start there and say, okay, how far was it from here to here? It's 1/8. That means that all the gaps have to be an eighth. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, and reduce. 2/8, 3/8, 4/8, 5/8, 6/8, because you need to go 4 beyond whatever this is. We'll put those all on the number line. We're considering what's happening with the amplitude. We have a baseline to consider. Down 1 means that your base that you're cycling around will be down 1 unit, like down here. So since we're going to be cycling around that, that's why I've got a little bit more as far as your notebook paper, because you're going to need to go down 2 and up 2 to do this graph. Our important places are going to be from 1 to -3. And it does show up neater on the next one, but just so you could see what's the thought process here. Okay. Then because it's a sine wave, you start in the middle and you go up, then you go to the middle, then you go down, then middle, up, middle, down, middle. Don't forget the middles. A sine wave starts on the base and goes up and down and up. So middle, up, middle, down, middle, up, middle, down, middle. Once you've started with the pattern, you just need to know where the pattern starts and which way to go. And you're just bouncing around between those, between going up and going down and round and round. Okay? And then you sketch it in. We have a nice sine graph happening here. And that's really how the pattern goes. You're always following the same thing. You figure out if the graph shifted up or down. You're figuring out whether or not it stretched out vertically. And you're figuring out where the shift happened and whether the graph compressed horizontally either. And the compression horizontally is the fact that it had this 4 here, made it squish up. And this one actually moved it, the whole graph. So let's get a summary here. This number will tell you how far up or down, whether you have a sine graph or a cosine graph. This number will tell you the amplitude. If there's a negative here, I don't have that written, but if there's a negative, it means it turns it upside down. This part goes between 0 and 2 pi, because for both sine and cosine, the standard period is between 0 and 2 pi. And putting this here, whatever it is in this section is going to help you to find the range for one period. It's going to help you find the beginning and the end, and then you can find the middles, you can find the gaps, and you can extend it. So that's about all I've got for you today. I hope that you are able to follow all that, and I can't wait to be able to get back in front of you so I can see your reactions and respond to your questions directly as they happen. So please make sure that you're playing this back and forth as many times as you need to. And I will just wish you a really good day and God's blessings.